Hello dear students, welcome to Pen and Paper Chemistry after a short water break. We are going to continue with our learning about the properties of phenols on the channel, and I hope the pen and notebook did not move from their place because we are going to practice writing some more equations. Continuing from where we left, we were doing the properties showing the breaking of the OH bond, and we are to cover acylation and benzoylation. Acidic nature has already been covered in the previous video. You can note down this chart or take screenshot, take a printout, keep it on the side like this so that we can use it to further help in writing the equations. What is acylation? Acylation is replacement of the hydrogen by an acyl group. That means CH3 C double bond O group. Under acylation, we have listed 3 reagents by which we can bring about acylation. So I can use a carboxylic acid, I can use an anhydride, so for example acetic anhydride, or I can use acetyl chloride in the presence of pyridine. So let us write these reactions. So here we've given the definition of acylation, that means replacement of hydrogen by an acyl group. This acylation can be brought about by reacting the alcohol or the phenol with carboxylic acid in the presence of an acid, by reacting with acetyl chloride, so CH3COCl in the presence of pyridine as a base, and the third is by treating it with acetic anhydride again in the presence of a base. So how do we go ahead? Now, if you recall, in the case of alcohols, we had said that alcohols react with carboxylic acids in the presence of mineral acid to give us an ester. Remember, we had flipped this over. So we had HOOCH3. And there goes our box to help us understand in an easy way to recall. Yes, this is not the mechanism, but these are simple steps to remember. So we get over here, start writing from here, C2H5O. Now this is our O again, CCH3. So C2H5O, C double bond O, CH3. Why have I written it like this? You will know once you expand the structure of the carboxylic acid that you have drawn over here. It is C double bond O, CH3. This is carboxylic acid. So there is a carboxyl group, a carbonyl group and a hydroxyl group. Combine these and you have a carboxyl group, COOH group. So this gets disconnected. What is available? It's the carbon which is available for bonding, which bonds through the oxygen, and we've got the ester over here, ethyl acetate. Now a similar reaction, because we've got an active hydrogen over here in the case of phenols, a similar reaction should take place in the case of phenol. So let me flip this over and I will have HO, C double bond O, CH3, form the box, and we have C6H5O, C double bond O, CH3. That is, we have phenyl acetate, or if we have to name it in the IUPAC system, it will be phenyl ethanoate. Right? There are 2 carbon atoms in this chain. Because this chain has the functional group, I am going to consider this as my main chain. Right? But the problem with this reaction is that this reaction gives me very poor yield. Phenols usually are not happy reacting with carboxylic acids. So esterification specifically in the case of phenols is not usually supported, right? It's not a very encouraging reaction as it is in the case of alcohols, where this reaction is actually used as a test for alcohols. So now if I want to introduce the acyl group, what do? Yes, resort to the second reaction. So let us write the reaction of phenol with acetyl chloride. So try yourself. C6H5OH. You have to react it with CH3, C double bond O, Cl. Now here again negative, positive, and you have positive and negative, correct? Tell me what will be the products formed. Should we again flip this molecule to help us make our boxes? Yes, that should make our work a little easy, correct? So I'm going to make a box over here. HCl is my side product. Now, first of all, see HCl, acidic in nature. It's a side product. I want to get rid of this. I carry out this reaction in the presence of pyridine. So the reaction is happy to proceed in the forward direction. Now let's form the products. Go ahead. Help me out in forming the products. C6H5. Start from the left hand side. Then you have O. Right? And then this becomes attached to carbon because now one valency of carbon is free and you have CH3. If you write this product as starting from the right hand side, so CH3, C double bond O, O, C6H5. Yes, then also it is correct. Both are the same products. But if you write CH3, O, C, O, C6H5, would this be accepted? Yes, even this is correct, right? But see carefully what I have written in blue. If I write it as C6H5, COOCH3, you see this structure? How is it different from the one that I have previously drawn? Let's expand it. C6H5, C double bond O, OCH3. That means it's a derivative or acetyl derivative of benzoic acid. It is not a derivative of acetic acid, right? So my product will not be correct. Here, if I see here, the C6H5 is bonded to the C double bond O, whereas in our original structure, look at how we've drawn it, C6H5. So if I were to draw it in the form of a ring, it would be O, C double bond O, CH3. This is how it is. Whereas when I'm showing the structure like the second one, then I'm saying it's C double bond O, OCH3. Understand the difference? So be very, very careful when you are forming the products. Got it? Have you written it down? The next method of acylation is treating it with acetic anhydride in the presence of a base. The base can be pyridine or it can be NaOH. Now, what is acetic anhydride? So, let's again simplify our learning. Acetic comes from acetic acid. So, CH3COOH, right? Let me take two molecules of acetic acid because we are talking about anhydride. That means from which water has been removed. So if I remove a molecule of water from these two acid molecules, what will I get? Now that you have removed water, try to join these two molecules together to form a single structure. Try it yourself. I'm going to expand the structure for you so that you can draw the structure again yourself. So CH3, C double bond O, OH, and you have CH3, C double bond O, OH. Now anhydride. Here goes my water molecule. How are you going to join the two parts? Very correct. So we will have, we remove the water from here. Now I have oxygen which is having a free valency. So this oxygen now comes to form bond between the two carbon atoms, and this is what I get as the anhydride molecule. It's the anhydride of acetic acid, hence the name acetic anhydride, or it is the anhydride of ethanoic acid also, so you will get to see the name ethanoic anhydride. When I want to form the product, what am I going to do? Yes, my simple funda, I am going to flip the molecule. So I am going to write it reverse. So CH3, COO, CH3CO. Remove a molecule of acetic acid from here. Now because we've got acetic acid as one of the products, I need a base in order to get rid of the acid, and we use pyridine or NaOH over here, OCCH3, and we can now form the product. Again, start writing from left. You see my arrow? C6H5O, OCCH3. The name of this product again would be phenyl acetate, or what was the other name? Write it down. Yes, phenyl ethanoate, coming from ethanoic acid. So let's have a full view of all the three reactions or of all the three methods of acylation. Treatment with carboxylic acid, treatment with acetyl chloride, or treatment with acetic anhydride. All of them giving us the same product, phenyl acetate, but the first reaction gives us poor yield, so we do not, usually in the case of phenols, we do not carry out this method in order to bring about acylation. Let us now move our focus to benzoylation. Now you know acylation. What would be benzoylation? Yes, simply the replacement by the benzoyl group. So for acetyl you had CH3CO, now it would be C6H5CO group. So you can write the definition of benzoylation, the replacement of hydrogen by the benzoyl group, that is C6H5CO group. If I expand it, I can also write it as C6H5C double bond O, and there is one free valency, and that is why I have shown a dash over here. So how are you going to carry out benzoylation? Easiest method. So we will have C6H5OH, our phenol, reacting with benzoyl chloride, C6H5C double bond OCl, negative, positive, negative, positive. Remember, we are doing the reactions of OH group, correct? So can you form the box? Oh yes, you already flipped it. Very good, well done. So let's make our learning easy. C double bond O, C6H5. And there we go. Our box is ready. Start writing from the left hand side. C6H5 O C double bond O C6H5. Now how are you going to name it? Of course, we've got the phenyl group, so write phenyl. If you see C6H5COO, C6H5COOH, what acid is this? Let me flip it around. It will be easier for you to correlate. Yes, of course, this is benzoic acid. In other words, this compound is a derivative of benzoic acid. Hence, we name it as phenyl benzoate. This reaction is known as Schotten-Baumann reaction, benzoylation of, in the case of phenol, that means replacement of hydrogen by the benzoyl group. Now that we have covered the first bit of our properties involving the breaking of the OH bond, we shall be moving on to the next set of properties, a very, very important set of properties wherein phenols show electrophilic substitution reactions. So be prepared for it in the next video. Make sure that you are writing while understanding as well. I hope we will remain connected. Till I see you in the next video, stay safe, stay happy, stay healthy. And if you feel benefited, please, can you share this gift of knowledge with your friends and classmates? Sharing is caring.